finish with the optics part, then hopefully we can go on to heat. Is that okay? If I'm not able to finish with the optics part, pardon me, we will schedule another lecture period within the week. Then we will continue on with that. Hope that is fine.
Yes, sir.
So today my main aim is to try as much as possible to finish with clear all the aspects of the optics part. Is that okay? That is my main aim. If just in case something comes up, I may also maybe pause the class for some time, or maybe stop the class, then you continue on the heat, maybe later within the week. But I just want to try and see if I can finish with the optics. Is that okay?
All right, sir.
But- so these things we didn't actually go through, but at least you should still know. And the optics really is very important. And I've taught this already. Is that okay? So you can just do a recap on it. The slide I'm showing to here is a little different. And pardon me again, I've not sent you your slides. I will update it right after the class. This time around, I promise. I'll update it right after the class and send it to you. Is that okay? So, we've done all this part. But the most important thing that we're looking at is light matter interaction. You know, I mentioned the last time that anytime light hits on a matter, when you say light, you are talking about the visible part. Is that okay? Don't you see, with the electromagnetic spectrum, we have different radiation. The one that is visible, that is the most important one here. When it interacts with any matter, a lot of things will happen. Is that okay? And these are some of the things that happens. We have something like the reflection, we have something like the refraction, we have something like the interference, we have something like the diffraction, we have something like the absorption and the what? And the scattering. As of now, we are done with the reflection, we are done with the refraction. I did a brief explanation on the interference and the diffraction. I will try as much as possible to finish all this section today. Is that okay? At least we should finish with the interference completely. We should finish with the scattering completely and the absorption completely. Is that okay? I'll finish all this part. Then we will end the class. Then within the week, we will schedule another 2 hours. Then we finish with the heat. Is that okay? So now let's go through what we've done so far. So we've done all these things. The light part. Is that okay? And the format. We didn't do Huygens construction. That is for those who be doing physical optics. So this one, I'll skip it. Then we did something we call the superposition of waves. I explained it briefly, but I told you that if a crest and a crest meet, it goes high. And if a crest and a trough meet, it dies off. And that is where we have something we call the constructive interference. And we have something we call the destructive interference. Is that okay? All these parts, we will skip it. It's for those who do physical optics. We will skip all this part. But the most important thing that I want us to do right now is the interference. Is that okay? So I'll try as much as possible to do only the principles of interference and do the second section, constructive and destructive interference, and do the third section, the Young's modular slit experiment. Then we will do maybe the fourth section, and that will be all. Is that okay? We'll finish very soon. So let's pay attention now. Now we now understand what a constructive interference is and what a destructive interference is. Do we remember something like that before I go on?
Yes, please.
Yes, please.
Okay. Can someone help me understand what a constructive interference is? Only constructive.
Okay, so the constructive interference happens when crest meets crest and then trough also meets trough.
Okay, perfect. So another person should also help me with the destructive. Who's helping me with the destructive? What's a destructive interference?
I'll say.
Sir.
Yes,
Mm-hmm.
yes. Frank.
Mm.
Okay,
So
sir.
that
All
okay.
right. Brother, please continue.
No, Frank, answer it. Charles has already answered something, so I want a different person.
Okay, so I'll say distractive interference occurs when waves meet out of phase. That's say crest meets trough.
So out of phase, it means let's say crest meets what?
Trough.
Oh, okay, perfect. So now, if we understand this, let's go on. And do you remember I mentioned something like the conditions that we need for an interference to happen? Do you remember something like that?
Yes,
Yes,
please.
yes, please.
So let me just do a recap. So when you say we need some conditions for interference to happen, there are two basic conditions that we need. The first one that we have to talk about is a coherent, and the second one is we need a monochromatic. And anytime you are talking about monochromaticity, we are talking about identical wavelength. Is that okay? So if the light we are using has one particular wavelength, it means it's monochromatic. And when we say one identical wavelength, in simple terms or in a layman term, you can just say one color. Is that okay? So if you are using blue, you are using only blue, a specific wavelength. Is that okay? If you are saying its coherence, it means that we want all of them to be in a constant phase. Is that okay? So if we have one wave like this, we need all the waves to behave like this. This we call it what? They are all what? In phase. So you can see that all the crests are following up here, all the trough are following up here. Exactly. So they are in phase. So these are the two important conditions that we need for an interference to occur. Now there's this man who did a very wonderful work with interference to actually and experimentally show us interference pattern. And his name is Thomas Young. Is that okay? And his experiment is called Young's double slit experiment, which we are going to go through. When you go in for your practical sections, you will do this one during your experiment. Is that okay? And use this proposal when you come here, we will show you how this is done. And other centers too, you'll be shown. And what he did was very simple and very phenomenal. You know, anytime we have a slit like this, and when I say a slit, a typical example of a slit is like you see when you are teaching the kids rectilinear propagation of light, you let them punch a hole at the center of a paper. Is that okay? So we can call that one to a slit. But here, our hole here is very small. It's within a micro. Is that okay? Diameter is very, very small. And that is what we are using here. So if we have light rays coming here, and again, our light rays supposed to be chromatic, monochromatic, and what? And coherent. Now, if the light ray is coming here, something happened here. Right after exiting, it behaves like this. And can someone tell me the phenomena happening here? Under which physics phenomena is this thing happening?
Interference.
Okay, that's a nice try, but it's not interference.
This is divergent.
No.
Diffraction.
Come again.
Diffraction.
Diffraction. Perfect. Is that okay? Diffraction. The first phenomenon that is happening here is diffraction. Anytime light hits or encounter any obstacle, a diffraction happens. Is that okay? So the very first principle that happens here is diffraction, but that is not of interest. Let's go on. It's interference that we are looking at. So we will create another slit here. But this time around, our slits, there are two. We have one here and we have one here. Then we can call this one S1 and we can call this one S2. In fact, we expect the same rays of light that has exited here to also go to S1 and S2. So let's look at this. Anytime this one exits, interestingly, if we place a screen here, we will see a very bright spot, a dark spot, a very bright spot, followed by a dark spot, a very bright spot. That is what Thomas Young was observing. Dark spot, very bright spot. And what he was observing is something like what I have here. I took a picture and sent it to you here. Is that okay? That is what he was observing. So the dark place that you are seeing is a dark spot, and the red part you are seeing is the bright spot. Is that okay? And I'm sure he used a red laser. That is why we are getting, or red lamp. That's why we are getting the red color. Is that okay? If you use a different color, you are going to see that color. And that is what he was observing. So dark red, dark red, dark red, dark red, dark red, you know. And all the places that we are having it as the red part is our bright fringes. All the places that we are having at the dark part here is our what? Is our dark fringes. Is that okay? So keep it in mind. We have the bright and we have the dark. Exactly. And the bright here, you call the bright here a what? A constructive interference. I explained this one to you last week, and the dark here as what? Destructive interference. And I explained to you how the waves were moving before we had the constructive and how the waves were moving before we had the what? The destructive. Now, so let's have explained all these things. This is a typical example, but I'll come back to this if there's a need. And let me show you this. So you remember I showed you something like this last week. Oh, I
Yes, sir.
didn't. Very
He
good.
did.
Yes. So, and I told you that anytime the trough here and the trough here are meeting and they are all moving the same phase, it come and ends up here, then we get a bright fringes here. So something like this, you see a red light. Is that okay? Another one here, you see the waves all moving in the same, then we see another bright light. But if the phases changes, then we are going to see a what? A dark spot. Is that okay? Now, let me skip all these things. There's some mathematical procedures that we have to go through to understand the Young's model experiment. But before I go on, do we understand the things I'm explaining here? We first have a slit here. Is that okay? Light passes through. We had diffraction happening here. We brought a second slit, and now we have two holes in slit 1, slit 2. And the same monochromatic and the same wavelength moves. But because the distance of movement may change, it may cause some difference in what? In diffraction pattern. Is that okay? And that is where we are getting something like a constructive and a destructive interference, because as it moves with different angles and all, we are going to get a place that we are going to get a bright and a dark fringes. Is that okay? Which is very important. So what I'm trying to explain to you here is our constructive and destructive interference are all happening here at different positions on the screen. Exactly. So this is our screen, but here you are going to see a bright light. At a particular distance on the screen, you're going to see a dark light, and at a particular distance, you're going to see a bright light. And we are saying the bright that we are seeing is called a constructive interference. The dark that we are seeing is called destructive interference. Is that okay? Are we good before we move to the calculation part?
Yes, sir.
Very good. Now let's look at something here. Now we have our source here, and let me zoom this one in. Whoa, here it is. Let's define some parameters here. Now this is the whole thing here. We have the slit that I showed you, and we have the screen. The distance between the slit here and the screen is capital L. Is that okay? And the distance between the two slits is a capital D. Is that okay? And we have our angle here. Is that okay? And we have delta here to represent That one I'll show you how this one came about. And we have our angle here, theta. We have the same angle here. Is that okay? And the other parameter that we have to know is the distances. Let's say we have one ray of light moving from this end to this end. We are going to call it R1. We have another ray of light moving from this end to this end. We're going to call it R2. Now let's imagine removing only this part of the angle out. Is that okay? So we are going to start from here. We remove the R1 up to the R2 and the distance D. And that is what we have here. Is that okay? If we have something like this, and anytime we want to look for the excess distance that exists between R1 and R2, that is going to be our delta here. Is that okay? And here we're going to call it the path difference between the two rays. Is that okay? And it makes sense. So if we have R1, we have R2. We want to look at the difference between the two of them, because of course the R2 is longer than the R1. Is that okay? So if you subtract the R1 from the R2, we are going to get our delta. And that is also equal to d sine theta, because we know that anytime you are finding for sine is what? Opposite over
Hypotenuse.
hypotenuse. So it's going to be theta here. The opposite is this delta, and our hypotenuse is d. Is that okay? If we make the delta the subject, we are going to get d sine theta. Is that okay? So relatively, the delta is equals to R2 minus R1 equals to d sine theta. Are we good?
Yes, sir.
So now, very good. So now let's keep this formula in mind. Let's keep this formula in mind. Okay. Yes. Atapo, your hands is up.
Yeah, sir. The symbol over there, the symbol that's R2 minus R1 equals to D sine theta. I want to know the name of it.
I think it's delta.
Please come again.
Delta. Are you okay?
Hello.
Hello.
Hello,
The
sir.
name is Delta. DELTA.
Okay.
Please say.
Yes, France.
Sir, for deeper understanding, can you take it over? Take the whole thing over again.
Okay.
We beg.
Oh, that's fine. I'll go through again. So now let's look at something here. It's just the definition of terms that I'm doing here. And what I'm doing here is the same thing that I showed you before, where we have two rays moving to form on a screen here, a constructive or any destructive interference. Now we are tracing any random point as P here, that is formed on the screen, that is at the top here, right? And from the definition of terms, I'm saying that the distance between the slit, so that is our second slit that we created, and the screen is L. Is that okay? And the distance between the two slits is what? Is D. Is that okay? And we have to also know that we are defining our ray going straight to the screen and another ray going straight to the screen here as R1 and R2. Is that okay? And now when you look at this thing, the most important thing that we want here is imagining the fact that we are removing only this angle from the screen. Is that okay? That is starting from R1 to P, then we come to R2 to say S2, then we take the distance here, the D, and that is what is ejected out here. Is that okay? Now here is assumed that the rays are parallel, so let's just assume it like that. Now, whatever being the case, we have, even with, when you look at it, we can see that this distance here is longer than this distance here. I mean, R2 is longer than R1. Is that okay? So if I want to find the excess distance from the R2, it means I can subtract this distance from this distance. And that is where I get the excess distance. And that excess distance here is a delta here. Is that okay? That's short distance here. Now, it means that I can see delta is equal to R2 minus R1, right? By just subtracting the R1 from here, I'll get this excess distance. We can imagine the fact that, let's say this distance is 10 and this distance is, say, 6. So if I want the excess distance here, I'll just subtract 6 from 10 and I'll get 4. Is that okay? And that is this excess distance. Now, let's just put this one aside. Apart from getting this, there's
You say you are awful. You say we can't hear you.
Hey, then I see.
And if you
I think it's on the network.
Yeah. Network na him high crowd. Yeah. Just a network.
disadvantage of online lesson.
Online media disadvantage.
It was supposed to be face to face, and we wouldn't be experiencing all these things.
Normal.
Last we couldn't finish with the second lectures. Yeah, we couldn't meet again. And this time.
How much we will see subject we are kako.
You're too busy. You're too busy. Sure.
And then teacher no baby man now. It's been a while too.
Stephen, maybe when a network problem in maybe he's having a network problem.
I think he's back. I think he's back. Oh,
No, he's not back.
you can see the screen. You can see the slides now. Oh.
Hello, please, can you hear me?
Yes, please.
Yes, we can hear you.
Sorry, my network dropped. And I'm trying to show the screen. Can you see it?
Yes, sir.
Okay, perfect. Where did we end? Which part did you hear? You didn't hear anything? Maybe let me say it that way. Because I was just talking, and I think no one was responding, and I got to know the network is down.
Yes.
Oh,
We said you should go over.
Okay, and I did that. Oh.
And you just started and the network jammed. This one.
So you go to the delta and the formula.
Okay.
R2 minus R1.
So yeah, so I was explaining the fact that if we have, can you hear me? If we have two rays like this, that we expect them to cause a constructive and destructive. One ray is definitely longer than the other ray. Is that okay? And if we have something like this, we want to find the differences between these two rays. In fact, the differences between these two rays is what we are getting the constructive and destructive interference from. And if we are able to find these differences, that is going to also inform us about what we are going to get at the end. Is that okay? And I'm saying that as far as we have one longer than the other, if you find the differences between the two rays, that is going to be represented as our delta. Is that okay? Now, we can also find, we have an angle here. We can also find the angle relating it to delta. Is that okay? I told you that the distances between the 2 points of slit is called the D, right? And sine, we are talking about opposite over hypotenuse. So here our opposite is the delta, hypotenuse is the what? Is the D, the distance between the two slits. And that is the formula that we have here. So here is opposite. So opposite is delta over D. If you make delta the subject, we are going to get D sine theta. Is that okay? So at the end, the delta is giving us two different formulas. That is R2 minus R1 equals D sine theta. And I want you to keep this formula in mind. It's very important. We are literally going to base on this formula for the rest of the two.
Please, sir, I have a small question.
Yes, ask, say.
So the opposite over the hypotenuse. I think we are looking at a right angle triangle here.
Yes, this small angle here.
So that one is a right angle triangle, but I don't see.
So I can draw this one as. So when we remove it and position it to all, it's going to be something like this. Is that okay? And this small angle here is going to be the delta. And this distance here is going to be our delta. Is that okay? So and this long distance here is going to be the D. So this one is going to be the D. And the perpendicular side is going to be this end, which is here, this end. Is that okay? So if I want to find theta, I have to get the sine theta. That's supposed to be my opposite. And here my opposite is what? Is the delta. Is that okay? So I can write the delta over what? Over D. Over hypotenuse. That is my D. Now, if I make the delta the subject, that is the most important thing here. That's the phase difference. It's going to be delta, the D goes up here. Then I'll get D sine theta. Is that okay?
Okay,
And,
sir.
and that is what I have here. Is that okay? So it's very important. This formula is very important. Let me go on. Now, as I said earlier, the phase difference, that is the delta, is what is going to inform us whether you're going to get a bright fringes or you're going to get a dark fringes. Is that okay? Now, if you consider the length that is approximately greater than, of course, the D, we have to also know that, as I said earlier, the phase difference is determining how the phase is going to arrive at P. Is that okay? So now I've mentioned this part. We can relate this formula to an order with what? With a wavelength. And this is what we just derived. This formula is what we just derived. What is here is what we just derived. And at this stage, using this formula is only when a constructive interference has happened at P. Is that okay? Using order number of say 0, using order number of say plus or minus 1, plus or minus 2. Is that okay? And using a wavelength just multiplying by the order number, we get a what? A constructive interference. Now, let's look at something. If in a situation of a dark interference, this time around, we are not going to get the phase difference to be of let's say, an integral form multiplying the wavelength. It's supposed to be add a multiple of, say, plus 1 over 2. Is that okay? And that is where we get a different shift of phases between the two waves. Is that okay? And now we are going to get, if something like that happens, it means you are going to get, let's say, trough meeting a crest or crest meeting a trough. In that situation, so someone is complaining he can't see the screen. Is it for only Solomon Nyako or everyone can see my screen?
I can see
We
your
can
screen.
see it.
Okay.
I can see.
So if that is the case, it means that we have to add plus 1 to the other number. And this situation, this is where a destructive interference happens. Is that okay? So anytime we are given a question, either find the wavelength, find the distance, find the phase difference, find the angle of a destructive interference. I beg of you, let this formula comes in mind. It's the same formula, but this time around we have plus half attached to the other number. And if the question asks of a constructive interference or for a bright fringes, use this formula. Is that okay? Now we all understand how we managed to come about this. Is that okay? This is coming from the order and the wavelength and the phases that you are getting. Is that okay? So let's keep this in mind. Please, is it okay?
Yes, sir.
Perfect.
Sir, please can you come back again?
Come
With
back.
with this one, the formula, explanation of the formula, only the formulas, please.
Okay, so I'm saying that we have two things that can happen on the screen. We can have constructive interference and destructive interference. Anytime we mention destructive interference, it is the same as dark fringes. Anywhere you see dark fringes, know that it's destructive interference. Is that okay? And I'm saying that if a question comes and you hear dark fringes, destructive interference, use this formula. This formula. Is that okay? And it's relatively the same formula as the constructive, but this time around, we have removed the half attached here. Is that okay? So here to any time in the question you hear bright fringes or constructive interference, you are using this formula. Those who will be doing physical optics in future, we will still repeat this. So when we reach there, it means I will not be talking about it again. Is that okay? So if you see the title of my slide, you can see that physical optics 2025. So it's the same thing that we'll be repeating in the future, but maybe you go a little deeper somewhere this the other. So it means we will see this one in future. Just a heads up. Are you okay for the formula now? So I'm just informing you about where and how we use the formulas. Is that okay? Here, when you hear dark fringes or distractive, we are using this, and we have half attached. And here we are using this. There's no half. Is that okay? So the question will give you the order, whether you are using order of 1, order of 2, order of 3, order of 5. They just write the order here. Then you to calculate for anything I want to calculate for. Now let's look at something here. I'm going to consider a different angle. The first angle that we considered was this whole thing here, starting from here, then it ended here. Do you see that? Where this one was our D, this one was our R1, R2. This was the first formula we used. I want to use a different formula. This angle, this time I want to use, I'm going to start from the Q here, move up to P. Then I'm going to start from Q here, move up to O, then move to O to P. Is that okay? From Q to O, the distance is L. It's written down here. It's L. Now from this time around, I can bring a different angle here. And anytime we have, I'm going to show you something like, if I have here as theta, I have L here, and I have this distance from, say, P to O is Y. Which angle should I use so that I will get Y and I'll get L in? Am I going to use sine, cos, or tan?
Tan.
You use tan.
Opposite over hypotenuse.
Tan.
No, tan.
Adjacent.
You use tan. Adjacent. No, adjacent over hypotenuse.
Hypotenuse.
Opposite to
Adjacent cos.
You are confusing me. Tan is what?
opposite to adjacent.
Opposite over adjacent.
Opposite over adjacent. Sorry.
Okay. So here opposite is what
opposite.
here?
Yeah, Y.
Y. Then
Opposite
my
of adjacent
okay.
is tan.
Okay. And my adjacent is
Adjacent is
L.
So if I make the Y the subject, it means I'm going to get what? L tan of what? Theta.
theta L.
So with this thing that I have, it's the same as what we have down here. Exactly. But if we are considering very small angles, very, very small angles, our tan theta can be represented in sine theta. Is that okay? So it means that I can get Y to be equal to what? L sine theta. I want us to keep this formula to in mind. Is that okay? So now under interference, I've shown you 3 formulas. One for the constructive, one for the destructive. And one here is Y is representing the other distances. And L here is representing the distance between the slit and the screen. Is that okay? So this is our second relation. Now let's look at something here. You remember this thing that I showed you earlier? We are just going to do a small substitution here. Is that okay? You remember these 2 formulas?
Yes.
Very good. Now, if we have Y to be what we have here, let's look at something here. We can actually, hold on. Okay, we can actually make the sine theta the subject here. This end here. Is that okay? Let's forget about the delta here. If we make sine theta the subject here, what are we going to get? Only these two terms.
M times the wavelength over D.
Very good. So we are going to get sine theta. Let me write it down here as M, the wavelength over what? Over D. And you remember the formula that we have here is Y equals what? L sine theta. Now I'm going to remove the sine theta. Is that okay? And I represent it by what Frank just told me. So if I remove, because I know this whole thing is representing sine theta. So if I remove the sine theta, I'll get what? M lambda over what? Over D. Do we understand this formula?
Yes, sir.
So if I have this, it's the same as what I have here. Is that okay? So I have my L here, I have my wavelength here, I have my order number here, and I have my D. We can literally also do the same thing for what we have here. Is that okay? Because here, if I make the sine theta the subject, instead of getting this, I'm going to get, I have to cancel the order number here. Then I'll get order number plus 1 over 2. All into a bracket. Is that okay? And if I substitute it up here, I'm still going to get this. And this is for a bright fringes, this is for a what? Dark fringes. Just a mere substitution. Is that okay? We are just substituting. Are we okay?
Yes, sir, please.
Now, I have shown you, if this one adds up, I've shown you 4 formulas. So let's just keep them in mind. This one, you don't have to do any barbaria. If you know these first 2, and you know the first one too, it's just a matter of substitution. Then you get this last 2. Is that okay? Now, I have a question here for us to try. Can you try this one for me? So a screen is separated from a double slit source by this distance. The distance between the 2 slits is this. The second order bright fringes is measured with a particular from the center of what line. The first one is I want you to determine the wavelength of the light and determine the distance between the adjacent bright fringes. So if we are to illustrate this, we have a slit here. And we have, that is a double slit, we have a screen here. What is the distance between the screen and the slit? From the question, what is the distance between the screen and the slit?
1.20.
1.20 meters. Is that okay? Thank you very much. Now, if this is what we are getting, what is the distance between the 2 slits? Was it given in the question?
0.03.
Okay, 0.03 millimeters. Is that okay? And if you remember the formulas that we dealt with, D, we're having something like D, we're having something like Y, we're having something like L, we're having something like wavelength, we're having something like, give me any parameter that you remember in the formulas I showed you. We are having something like theta. Very good. We are having something like M. You remember all these things, right? Now, if we have, with the formulas that I also shown you, what was D? What was D representing?
The distance.
Distance between the 2 slits.
Very good. The distance between the 2 slits. And here the D is this one. the distance between the two slits, right? What was L? So now we know the D. What
And
was
that's also the difference between
The slits and the screen.
the wave.
The
and the
screen and
screen.
the slit.
very good? Thank you. So that is our L, and that is given here, right? Now let me show you something. What about now? Let's hold on to the theta. We are to find the wavelength, so that is another thing to look for. But I want us to look at something. Do you remember why?
Uh,
Why is the sign?
Yes, sir.
why
Tell me
was
why.
L sin theta.
Hmm?
No.
No, not the
Why
formula.
was
Here,
L
the formula.
So, is it for the bright or the dark?
No, not the formula. I want the description of the y. Like the way you told me the d is the distance between the 2 points of slit.
so
Other distance.
The other
why
distance.
was
Mm-hmm.
the distance between the points where the arrow one reached, which is the P,
Mm-hmm.
and the O,
Okay.
that horizontal distance between the two small holes on the
Is it
slit.
horizontal or vertical?
The Y is a vertical distance.
Mm-hmm. So this is the y. So from the center line here to where we had either the constructive or the destructive interference, that is going to be our y. Is that okay? And that is what is given here. And it means we know the d, we know the y, we know the l, we don't know the wavelength. We are here to find for. Do we know
Sir,
the m
sir, please, can you come over again with the Y?
with the y? Okay. So the
Okay.
y, look at the y. The y is the center. We call this line the center of line. Is that okay? It's the center between the two slits. And it is where we had our fringes happening. Is that okay? Up to the center of line. Is that okay? So let's say we had a constructive interference here, and that is where we are interested in. It is that point to the center of line. Is that okay? Let me go back and show you something again. When you look at something like this, okay, the first scenario here. Okay, hold on. Let's go look at the second scenario. The center of line, you see here, my center of line here is P. So the distance between this end here and this end here becomes my Y. Is that okay? The distance between the R here and the P becomes my center of Y. My center of line becomes my Y. Are you understanding?
Yes, sir. Thank you.
So, madam, look at this. If we have a situation like the first scenario, what would be the center of Y? And the Y, would we get a value for the Y?
Sir, please come again.
If we
Why
have a
will be zero? I
scenario
think
like
that
this,
will be zero.
if you have a scenario like this, what would be Y? Can you figure out
Ze-
a value for me?
I think the Y will
Zero.
be zero.
Y will be
why
zero.
is zero?
Is that because Y is also at the center of the line? They are all lying on the center of the line, so to be zero. But here we can figure out a accurate distance for it. So that's just by the way. So now from the question, we've derived D, we've derived Y, we've derived L, we've derived M. The only thing that we need here is to find the wavelength. We are not giving angle. So you have to determine which formula that you're going to use. That would be very appropriate here. Is that okay? Should I leave it for you to try? Okay. So I'm
Let's do
giving
this
you.
together.
Come again.
Let's do
So
it
we'll
together.
try.
No, try. If you do it together, you will not understand the next question. So I'm giving you only 10 minutes. Try your hands on it.
No, sir, let's do it together, please.
No, sir, Kwabena, you try your hands on it. I've literally done it for you. I've shown
Okay,
you the
then
parameters around. I told
give
you
us,
that we have D. I
please.
told you that we have M. We have Y. We have L. We are looking for wavelength. The formulas that I've shown you before, use the formulas. Look at which of the formulas is appropriate for solve a question like this. That is all.
But
So, sir,
but sir,
screen us the
which
formula.
how would you identify that this one is a bright fringes or okay? They have already indicated it over there.
It is in the question. Yes, just take your time and read.
Okay.
I can't see the screen. Oh.
Sorry, I did a mistake. I'm coming.
Please, I just joined. What's happening?
Can you see the screen now?
Yes, please.
Yes.
So find for the wavelength for me, and when you finish, you find the adjacent.
It's blur. It's blur.
It's Blair. I think it's the net. It's your net.
Okay.
Exactly.
It's okay now. Patience, please. We are solving the question on the screen. Okay.
Okay, thank you.
If you want to look at the formulas, you can tell me. Then I'll go back there and check it up.
Yeah. Please say we should represent the answer in what? Nanometer, right?
Yes, nanometer.
Okay.
Please, let's look at the formula once again.
Go back to the question.
Yeah, we are done.
So like, please hold on a bit. Let me get about 2 hands up again, then we solve it together. Or you tell me what to do and
Okay.
solve.
Okay, sir.
I'm done, sir.
Okay, so like, still hold on. It's Frank, hold on.
Okay.
Lucky and Sir Frank, who again is done, please?
Sir, please, I'm also done.
Perfect. So maybe Sir Lucky, can you describe? No, can you give me the answer? Sir Lucky.
Yes, sir. The first one I had the lambda, the wavelength I have 0.5625 meter.
The answer was particularly given to us to leave it in nanometers.
Okay, so nanometer.
And
So 0.5625 nanometers
Okay.
for the
So
lambda.
can you hold on?
For the lambda. Okay.
Okay, can you hold on? Sir Frank, what did you get?
So I had 5.625 times 10 exponent negative 16 nanometers.
it said the first answer.
So I'm saying I had 5.625 times 10 exponent negative 16 nanometers.
Sir Lucky.
Someone is interfering. I can't hear the last part.
Hey,
So
Assemble
I'm coming again. I had 5.625 times 10 exponent negative 16 nanometers.
Negative 16 nanometers.
Yes, sir.
Okay. I want a different answer. Was this a child who was finished? Any different answer?
But I think mine is also like that of the last answer. 5.625 times 10 negative
So
16.
with the first one. So with the first one.
That is
I don't know how you're doing it, but there's a mistake somewhere.
So let me also try. I also had
Yes, madam, I'm listening.
I also had 562.5 nanometers.
Yeah.
Okay, so I also had
Yes,
please,
I'm
I
listening.
also had 0.004 nanometers for the lambda.
Okay.
So
Yeah, I want another different
I
answer.
also have 562.5 nanometers.
So, Samuel, how did you do it?
So I first convert them to meters for my solution. Then my final answer, I convert it back to nanometers.
So hold on.
So
For this particular one, when you convert it to meters, what are we getting?
for the meters, I got I had the lambda to be 5.625.
No, not the lambda. The distance. Now you see, the distance between the slate and the double slate and the screen is already in meters.
Yes, yes.
But the distance of that of the two slates is in millimeter,
Yes,
and
yes.
the other is in centimeters.
For the D, I multiply I multiply by 10 raised to the power negative 5 because I removed the point. 1, 2, 3, 4 into meters. So I got.
Then you had what?
I had 3.00 times 10 exponent negative 5 meters.
Okay.
And then the distance of the spring from the Y2. That one to I changed to centimeters to meters. That one to I got 0.045
meters. Perfect. Okay.
Meters. Before I substitute the
Which formula are you using
equation. Sin theta equals to the order of frames times the lambda, and by rearranging them, I made the lambda the subject.
But what is
So
theta?
I use,
How did you get the theta?
I say you in your explanation you said that sin theta is approximately to the distance between, that is the y over the l. So I use that one.
Okay. So I'm listening. Can you continue?
So I substitute where the sin theta in place of the y over the l. Then I made the y2 the subject from the equation. So I got lambda equals to the y times the d over the m times the d.
So you had lambda to be equals to y d.
Lambda equals to y d over m d. ml, sorry.
ml. That is so perfect. Great. So now do the substitutions for me now.
So the substitution will be the m, which is 0.045 in meters, times the D, which is 3.00 times 10 is for negative 5 in meters. All over the fringe distance, which is the 2 times the distance to the screen. That's one which is 1.20 in meters. And then I, I first calculate the top one and then the down one. So for the numerator I had 1.35 times 10 is for negative 6, and then the denominator I had 2.40. Then later no, I point the two of them on my calculator. Then I had 5.625 times 10 is for negative 7. And then after that, I multiply all of them by 10 to negative 10 exponent 9 in nanometers.
Is it not supposed to be negative 9?
Nanometers is negative 9.
It's negative 9.
If it's supposed to be negative 9, then I'm a bit confused here.
If it's negative 9, then the answer will be 5.625 times 10 exponent negative 16 nanometers.
So please, this one there, I beg you, come in for us in converting it
Oh, but what you
to
said from the
nanometers.
beginning was right. It's just that the nanometers should be negative 9.
Hello.
Why it's supposed to be negative? Can someone help me?
Solution has been placed over there.
Okay.
Listen up. Let's be very careful about our conventions here. Is that okay? So I think how you started was very okay, so 7. But the latter part is the problem. So check that part, or whether it's your punching of the calculator. If you are having some times the power something at the denominator, let it reflect. And if you do that, you're supposed to get negative of the answer that maybe you are looking at. It depends on how you did it anyways. If you are doing it this way, at the end, maybe you are getting something like this and you remove it, then you get a nanometer in the scale. Is that okay? Apart from that, everything that you said is very perfect. So someone, are you getting me?
Yes, sir.
So just do check your calculation, your function of the calculation. So as he said earlier, the best way to go about this is to change everything into meters. That is the safest way. So we have our L in meters already, our D converted to meters, our other spacing converted to meters. Is that okay? Then there's this formula there. This formula that was given, it was y equals something. And because we want the wavelength, angle wasn't given here. So don't worry yourself, use the formulas having angles. Just go straight to the point and use this. You are giving y, you are giving d, you are giving the order, you are giving l. The only thing you need here is the lambda here. That is our what? Our wavelength. We want to look at which wavelength he used in this experiment. And when you do your substitution, in simple terms, we are just getting this. Is that okay? Which is quite straightforward and simple enough. Any question for the first one?
Yeah, sir. The conversion, the split, the sleep distance. if you want to convert the 0.03, so the this will move 1, 2. So I don't know why we get negative with the power -5.
I have. Can someone help me here?
Yes, sir. For the 0.03 millimeters, that one, you see, 1,000 milliliter is close to 1 meter. So you divide the 0.300 by 1,000, then you get that particular figure over there.
This thing that I have here, it is the same as me writing 3 times 10 raised to the power -2 mm. So, Lucky, do you understand this one before I move on?
Then my answer was correct,
Yeah.
but you didn't say anything.
Am I the only
Okay,
one? Not...
Yeah, madam, it was very
Because
correct. I
yes,
just wanted someone to explain it so that I see.
just that you made the 0.5, you run it to the nearest, and then you got the 563. But mine was 562.5.
It's in range. Don't worry, it's fine. So, Lucky, do you understand this? If we have this, it's the same as this. Do you understand it that way? This point here move from 1, 2, and it will bring a -2 here, still in millimeters. But I'm not interested in the millimeters. I'm interested in meter. If I want to remove this milli is 10 raised to the power -3. So 10 raised to the power -3, it means I'll get 3 times. I already have 10 raised to the power -2 there. If I come and add the -3, then I'll get a -5. Is that okay? Then I'll bring my meter there. In fact, if you are given a question like this, you may be very good with the substitution and the arithmetic and the formulas, you know everything. But trust me, if you do a mistake in any of this end, everything goes down to the drain. Is that okay? The maker might not even consider you. You may come out, oh, this one, it was easy, I did it. But maybe because of some small mistakes that you did at the initial part, everything goes down. Is that okay? And you can imagine the fact that the wavelength that you're going to use here is the same thing that you're going to use here. And it means if you get this place messed up, the subsequent question 2 is going to mess up. Is that okay? Okay. So let's be careful with our convention and other things. Is that okay? Let's be very vigilant with it.
Okay, sir. Please, if you can take us through the nanometer. One, the final answer in meters that we are converting to nanometer.
Okay, so I had this answer, right? When you punch this whole thing in the calculator, if I move the point here from 1, 2, it creates another 10 raised to the power -2. So it means I'm going to get my 5, 6, 3 times 10 raised to the power -2. But you know, I already have -7 sitting there. So times 10 raised to the power -7. Is that okay? So if I have -7, -2, I'll get what? -9. And in prefix, n here, nanometers means -9. So it means I'll ignore all these things and bring the -9. That is n. Now, did anyone get the same answer as what I have here for the number 2, for the second section?
Yes, sir.
Yes, sir.
Okay, can someone help me take me through? Yeah, okay. Can someone help me take me through? Madam Patience. Who's helping me? If you didn't use this method, don't worry. Just tell me how you managed to get the 2.25. Is that okay? Forget about what I've done here. Just tell me how you managed to get a 2.25. Anytime we have a slit here and we have a screen, and this is my center of line. I've explained the center of line to you already. Is that okay? In interference and in order naming, we call this zeroth order. If I move up, anything that I see is my first order. Anything I see is my second order. Anything I see is my third order. Anything I see is my fourth order. Is that okay? And if you come and do the experiment in the lab here, we will use something we call the spectrometer. And we will let you look through and you see at each order here, you see a very bright light. Is that okay? So the zeroth order, you see a light. First order, you see a light. Second order, you see a light. Third order, you see a light. Fourth order, you see a light. The same way, when we come down here, anything that is happening at the top here is happening down here. First order, second order, third order, fourth order. Then the order continues. Now, in what we did, our interference happened at which order from the question?
Two.
Second order.
Okay. So the second order, it meets here. Another one comes here. It meets here. The second order. And the second order, we are told the distance between the center of line and the second order is what?
Another 4.5.
What is the distance?
4.5 centimeters.
No, in the question, they gave me 4.5.
4.5.
4.5 centimeters.
0 centimeters.
Now, I am not interested in the 4.5 here. I'm interested in the adjacent order. Is that okay? Where when we say adjacent order, we mean any order that is close to what we have now. Is that okay? Because the question wasn't specific, whether adjacent to the top or adjacent to the down. So we are interested in either 1 or 3. Any of them that you use is fine. So I am interested in the adjacent order. That is what is going on here. Is that okay? So any of them. Now, fast forward. Let's look at this. In fact, in the mere looking at the question and understanding how I have drawn it, and you understand what is going on, you should be able to tell me the answer. Is that okay? Because we started from 0 and we are 2 and it's 4.2. If I want the one in the middle, what will I do?
Divide by 2.
Divide by 2. That is all. This happens because we are the second order. But let's go if, say, the question we're in the third order and it's 4.5. It may not happen like that. And the examiner too will not understand that we just write 4.5 divided by 2 and you write the answer there. No one will understand that. Is that okay? So we have to do some mathematical ways, bring in the formulas to get it. But at least you get a fair idea that I'm expecting an answer around 2.25. Because when you divide the 4.5 by 2, you are getting 2.25. Exactly. So now this is where we come back and come and write. If we are at the first order, we want to find the differences. This is my second order. And even the formula that I have here is looking at the adjacent order, that is the 3, because I have my M here, plus 1. If my second order, that is 2, m here is 2 here, is that okay? Because I'm using the second order.
Yeah.
So 2 plus 1, I'm getting 3. I want to look at the difference between the second order, that is the 2, is that okay? So I can write 2 here, and I can write 2 here. You already know the formula when we are talking about y, because y is given here as what? The lambda length, the order divided by what? M. It's the same thing we are using here, the lambda L divided by M. But this time around, the M here, we've added 1 to it because we are looking for the what? Adjacent order. If it tells you look for the next 4 orders, you come in plus 4. Next 5 orders plus 5. Adjacent, just adjacent plus 1. Is that okay? Then the rest he left here is just substitution. But here, for simplicity's sake, I actually subtracted this one from this one so that I'll get this and did my substitution. If it will confuse you, forget about what I've done. From what we have here, you can just do your substitution here. Come and put the lambda here, come and put the L here, come and put the D here. We know all these things from the formula. Come and put your order here is 2. Fine for this first term. When you finish, fine for the second term, then you subtract, you will still going to get the same answer. Please, is it okay?
So are you adding will you add the 2 plus 1? So that'll give you 3.
Perfect, yes. We are looking for the adjacent.
Okay.
Is that
When the
okay?
question says the adjacent, that means we have to add 1.
If it says adjacent, we are looking for the close order. It's either we are looking for 3 or we are looking for 1. Is that okay? Someone can say, I will not look for between 3 and 1. Sorry, 3 and 2. Someone will say, I will look between 2 and 1. That one too is correct. From what I'm doing here, I'm looking between 3 and 2. Because when you look at down here, it's 2 plus 1, I get 3. And this order is 2. So I'm looking between 3 and 2. It's adjacent. We can look the one above, we can look the one below. It's still going to be correct. Is that okay? We can decide to look between 2 and 1. That is fine. So that we get something like ym minus y m minus 1. This is correct. This, I'm looking between 2 and 1. You do this, you're going to get the same answer as I've done before. Have I confused you enough?
Yes.
Okay, I've confused you enough. It's good. So can we go on? Good.
Yes, please.
There's a second question here. Let me still pause again. Then let me see if you can try your hands on this for me. Here we are finding for only the wavelength. It's the same as what we did before. But let me see if you can still do it for me. So we are using only 10 minutes. I'll come back very soon. Within 10 minutes time, I'll come back. Is that okay? I'm checking up on students upstairs. So 10 minutes. Please, is it okay?
Yes, please.
Yes.
Okay.
Yes.
Please, I just joined. Please, which page are we? Which page are we? Can someone help me?
We are solving the question over there.
Please, which page on the slide?
Yes, on the slide. The question on the slide. That's what we are doing.
Okay. Okay. Thank you.
Solving the question. He has been given a question. And he has given us 10 minutes. And that is the
All right. Thank you.
Hello, class. Is somebody done?
Yes, I'm done.
Can we compare answers? Like,
I've gotten 3.143 times 10 exponent negative 7 meters.
yes, yes. So somebody should also, compare, and let's move forward.
3.143 times 10 raised to the power minus 9
Yes.
nanometer. I don't know if that's the.
We are
But
coming in
they
meters, not
did
nanometers.
tell us to change it to the nanometer. Okay, so in meters, the answer is right, but in nanometers, then we should get the 314 something. Yeah, 314 nanometer.
This one you have to change it to nanometer.
Yeah, that you didn't specify, so I think we should leave it to meters.
Wavelength straight away, so
Yeah.
it should be.
So it's in meters.
Friday.
Let's try to concentrate on the second one, true or false one. If false comes there, we are done ourselves. So we said a larger slit creates a larger separation between interference fringes. How do you understand this? You say you justify your answer.
Yes.
That's it.
I don't know the room fast or the whole sense. What was the first answer, please, if I may ask?
3.1428 times 10 to the power negative 7 meters.
3.1.
1428. Or you can run.
Me, I ran it, so I got 140.
Run. Okay. So the true or false one is where we are. Let's share ideas, please. Before seconds, then we had, touch on something. Patience, bring your mind.
About
what? Do you think? The true or false one.
Why don't you share yours?
Please, before we go to the true or false, please, I want to understand something.
Okay.
Hi, please go to the true or false. I want to ask questions before, because I'm not getting things clear here.
Come with your question.
Can I proceed?
The faculty is still here.
Okay, please, with the parameters that we wrote, the y is the 1.4 meters, right?
No,
the y is the position of the second order. So it's going to be the 4.4 centimeters.
Then you change it.
The y is what?
You change it to meters. 0.044.
So the y is added the 4 point, and that would be 0.044.
Yes.
Okay. And the 1.4 will be for the L, which is the length.
Sure.
Yeah.
Okay, so I think I made a mistake of interchanging the parameters. Okay, thank you.
Welcome.
And with the second one, I think is false.
Yeah, justify your answer.
Yes,
True.
explain further.
Okay, so this is my explanation. We know that the slit distance, which is the D, is inversely proportional to the how do I call it, the change in wavelength. That is the separation between the interference fringes, from a formula I got, which is the separation distance between the fringes, which is the change in the wavelength, equals the wavelength times the L over D. So from there, I've realized that they are inversely proportional. So while D decreases, the change in the wavelength, which is the separation between the interference fringes, will increase. So that's why I'm saying false. It is false.
I'll go for true.
Yeah, previous.
I would say it's true because it will be true because a larger slit creates a larger separation because between the interference, because the diffraction pattern becomes more spread out as the slit width increases. So the small hole, as what they call it, as the interference increases, for me, I think that the holes will be, as it's spreading out, the holes will be increasing with the width. That's the size of it. So that's why me, I think that it will be true because as a larger slit creates a larger separation, the diffraction pattern become more spread out due to the slit wide increases. That's how I'll go for false. I'll go for true, rather.
Okay. I also go for
Okay.
false. I
It's
second.
false.
And I think these kind of things, we have to use a formula to prove, not just by assumption, because the formula will
Yes,
make it very
because
clear for us. So from the previous question we solved, that we were asked to find the distance between the adjacent. I don't know if you can all remember the formula brought on screen, which is the wavelength times L over D, then M plus 1 minus wavelength L over D times M. Yeah, and then he had a final answer like, or he derived something like wavelength times L over D, which is equal to the distance for the adjacent fringes, which is the change in the Y. So right from that formula, you can realize that the distance between adjacent fringes is inversely proportional to the distance between the slits. So from there, you can conclude that while the distance between the slits decreases, making them inversely proportional, proving the statement that they have said over there false.
False. Okay.
Okay.
False. Okay. I think I understand yours better than. So I think false will be. Yeah.
Even again, the separation between interference fringes is determined by the distance between the slits, not the width of the slits. That's what I think too.
Okay.
So will you go for false or true?
It's
I think it's
false.
false. Yeah, it's false.
Yes.
Because the larger slit separation decreases fringe spacing. Yeah. So the statement is false.
Okay. Please, I want to ask a question. This is a patient. I don't know. The first question was the distance. If the fringe say was like y, is it m plus one something like that? He said if the question didn't specify. Is it fringe? The first question work, not this one. And the last question, the distance. I was a little bit confused over that. When you say m, he dealing with the between two, looking at 2, 3, something like that. 1 or 3 or 2, 3 or 2. Because
and the first question is what different.
Correct. I don't know if anybody can.
Yeah, they was talking about the order. So the order was on the second. The order was on the second. So he was comparing the second and the third, or the first and the second order. So that was what he was just talking about. So here's my question.
Okay, then I'm wrong because I changed everything.
With this one that we are doing or what?
Yeah, the first one.
No,
I got
not this one. My question.
Wait,
the did it indicate either is the first or the whatever what do you call it? So he said the one that's closer to is it the 0 or something like that? 4 points.
This one that we are working.
Yeah, not this one. The one we work before this one. The last question.
Yes.
Where he was saying that m plus 1 or something like that. The formula. Yeah, you're still not getting me.
These questions, I think they will bring the same thing to our exam. They will not change anything.
All right. Thank you all for your contributions. Yes.
As long as I have understood
So
it.
let me also bring mine on board. If you understood it.
Please, can you come over the true or false? The first one, I beg.
So the true or false one.
Please, with all due respect, please with the first I think we said answer is false. This question we did on the distances. I think the first the distances. First finding the distances. I want to know the formula we use and
We use what do you call lambda is equal to d.
Please, I'm listening. Message, please, I'm listening.
Hey, someone else should kindly help me. I'm not feeling well, beg. Please.
Stephen. Steve.
Please, I can hear you.
For the first one that we saw, you are saying that the length at the center. Are you listening?
Yeah, we are listening.
Yeah, I'm listening.
He was asking about the formula.
Stevie, mute yourself. Mute yourself so that we can hear him, okay? Mute yourself. Paul, you have muted, or you have unmute yourself. You have muted yourself. Paul, you have muted yourself. Paul.
Stephen, I think you were asking about the formula that the lecturer was using. Stephen, please come clear with your question so that I'll be able to.
Okay, so please can you hear me? Hello, please can you all hear me?
Yes,
I can hear you. I can hear you.
Okay, I was asking that with the first question that we solved, the distances we solved, finding the distance between the two slates or the interference. I just sent distances. No. First of all, I didn't get it all. I didn't get it. With the formula we use,
So for the two fringes, is it that you find change in the y, and when you are finding change in the y, you equate it to the y, because there's some displacement over the y m plus 1 minus y m. So you know the formula for the y, and you know the formula. So you replace the y with its formula. You know that y is equals to lambda L on D. Lambda L on D. So you replace this. The only difference is that when you are finding the change in y, because the displaced fringes, we are having m plus 1. That is the adjacent fringes. We are having m plus 1 attached to the change in the first y minus the next y, which is ym. Until we are afterwards, then you replace y with lambda L on D. Please, are you okay with that one, Steve?
Okay, so it's only the changes will only affect the y. Wherever you see replace it with the formula, which is lambda L over G.
Your line is breaking. I don't know who's talking. The line is breaking.
Your line is breaking a lot.
I think it's okay now, Anna. Please, can you hear me now?
Yes. You can talk now.
Yes, we can hear you.
Okay, so what I was saying that if change of y is equal to ym plus 1 plus ym. That means that wherever you see y, you replace it with the formula of lambda L over D.
Exactly. That is how it is.
Okay. Thank you.
You're welcome.
And so you will use the parameters given in the formula, the initial one that you use it to solve the same thing.
Yes, that is what you use. There's no change.
Okay. Thank you.
I think, thank you for the explanation, Lord. I think that's why I also got confused. Because I was thinking that the m plus one and those kind of things. So the basic this thing is that the change of y just equal to lambda L over on D. I think that's the simplest understanding.
With the slice that say is using. The slice that say is using, I don't think if we are having the same slice, because the interference for the one that he gave it to us, the interference, we don't have that formulas and those things there. I don't know if I'm the only one having that problem.
We have to tell him so that he update the slide for us. Then
It's
we
true.
use
It's
that
true.
one.
So we are waiting for the updated slide.
It's true.
You have to.
It's true.
So he says he will share the slides. I don't know if he has shared.
He said he will
No,
do that
he
at the end
hasn't.
of
He
the
said he
class.
couldn't do it, so he promised to do it today and send it to us. So this time we have to pressure him because we have about this
2
week or
weeks.
next week. Then we go for the
And
quiz.
please.
Next week, I don't think we're going to meet. We are going for the practicals next week. So you have to get it. You have to pressure him.
Steven.
Yes.
Yesterday I sent you a WhatsApp. I called you. I never heard from you.
Sorry, I was in church and I tested you after church on SMS, and you also didn't reply me too.
Hey.
Please charge this one backlog. Why?
Thank you, sir. Thank you, sir. Pacho, I say physics I say is it because I say previous one light and minim. The only difference is the history about Rutherford and Daltons and atomic structure no pen new one from, but meaning say menkwana mehuni sa.
Okra, yes, name.
I think it's because we are doing everything online, but from the content, most of the topics are not too difficult like that. But you see, we are busy online working, so many things, family system
We are
or everything. Yeah, so
everything, combining everything. So it will be difficult for us. Unlike those on campus, all they are doing is learning.
just put the passcode, send the passcodes to the platform so that it can help us.
And who here pa, and who here papa. Pasco here, Mislamu. Yeah, physics group. I think we have a physics group there. At least for Pasco Nungum, any should I access of past questions. Me, I'm Mislamu. We was me say I can't learn. It's only the past question I used to learn.
Past questions, I think a past student, yeah, Bob Mubian Sank, auntie. I think she said you call UCC for practical next week, and they call printing press on, and you bring some of the regular past questions, maybe now, yeah, they are to platform, so, and this are there. She said, I think from next week, you call UCC center, why you bring a duo. And here, and second, the better platform, no more wait, will be answer can be but now make us the other aspect of course Nigerian mechanics, in fact temu pound I didn't say regular for book no share their mind and see over one section within the whole day. What's now one? Ube every day, won't be that. And to make us say, can you a year when you share lecture now? And then in Casano or man slide the moment and more introducers and they bet me a boy because that book night of on the offer one session now to take you about the whole day to read. And there are more units and sessions. And then Casana on based on slide on your slide it be my I think say me who one slide there was West School for platform so back. Yeah, lecture and see different no. So bet me am my media analysis or bet me I recommend it West School for them so am na yeah sure
No, we are all
and this
doing the
idea
same thing. At the end of the day, the same questions we are all going to answer the same questions. If you have that one, just put it on the platform so that we go through that one too.
I
okay,
think
I'll put it.
with the Newtonian mechanics, it's like we have a problem because we just today will be our last session. We are not even done with
Yeah.
Unit 2.
We couldn't finish the other day,
Yes, yes.
last week.
I think yes. There was he scheduled, but he did not.
He didn't
Yeah,
come.
that
He
was
didn't say
Sunday.
anything to us.
Please,
All
so
right. I think our lecture is around.
I think the lecture is back, so let's concentrate.
Okay.
Please, are we done with the questions?
yes,
Yes,
please.
please.
Okay, great. I'm also handling the regular student around. That's why I'm multitasking. Sorry about that. So what did we get?
So for the first one, we had 3.143 times 10 exponent negative 7 meters.
It's different from what I have here. Or let me see the answer. Okay, I think this is a different solution. Okay, this is a different solution. Different. So you said you had 3 points what?
3.14 times 10 exponent negative 7 meters.
Any different answer apart from Frank's one?
No, sir.
So Frank, can you take us through?
Okay, so the formula, we know the wavelength to be equal to YD over ML. So first of all, the D was given in millimeters. So we change it to meters. We had 2 times 10 exponent negative 5. Also, the Y was given in centimeters, which is 4.4. We change it to meters and have 4.4 times 10 exponent negative 2 meters. So I substituted all that and had the 3.14 times 10 exponent negative 7 meters. Hello, sir.
Hello, Frank.
Continue.
Hello.
Yes, sir. So that is it.
Okay. I was asking if you discussed it together when I wasn't around.
Yes, please, we did.
Yes, we did that.
Oh, okay, then that's fine. Can you hold on?
Please mute yourselves. You are disturbing us.
So I want to show you something different. So this is for the interference part. Is that okay? So what I just shown you is very important. In fact, the practicals that you come to do here we have one experiment that is highly based on it. Is that okay? So please, let's not forget about these formulas. Is that okay? And I think it's very, very easy. when you look at it, you just have to read the question, understand it, then you look at which of the formulas that is going to help you solve it. Is that okay? And that is all. Are we okay?
Yes, sir.
Perfect. And I think I also showed you this. Let me see. Some of these applications.
Sir, your screen is not showing. I can't see your screen.
No, hold on. I'm now trying to project it.
Okay.
I'm looking for something. Slice in the big one and be a big habit, you know. I'm showing something now. Okay, so I think I shown you this. I've told you this before. The application of this interference is okay, and we call something thin film interference. We are not going to do it, but I'm just showing you that under interference too, these are some of the things that we can get from it. Is that okay? It's not always dispersion that can give us nice colors of pattern. Interference too can give us a very nice colors of pattern. Is that okay? So let's keep this in mind. So do we have any questions so far? I think from now we can just move on to heat. We've done enough in the optics part. Yeah,
Just a quick question. Yes, sir.
Yeah, hello, Yima. Lucky, sorry.
Yeah, yes, sir. The question we just work. The one we finish working right now. The second part of the question are true and false question. I don't know if you can clarify that.
No, don't worry about that. The only one that I wanted you to do at this level is the first one. The rest, let's forget about it. Is that okay?
Sir. Thank you.
And I told you
Thank
that.
you,
And I told you
that.
this slide.
So does it mean it will not come to the exams?
This slide is the physical optics slide. The one I want you to know is what I'm showing you. Is that okay?
Okay, sir. Okay, sir. Thank you.
So don't worry.
Let's move forward.
Are we all okay with the optical part so far?
Yes, sir.
Perfect. So what is left for us to do is the heat part. Yeah, Seima, your hands is up.
Hello, sir.
Yes,
Please,
sir.
with the updated slide, if you can just after the lecture, if you can do that.
Yeah, so we need it badly.
Yeah, I'll send it right now. If I don't send it right now, it will be a problem because I'll forget again.
Yes.
So today I will not do the heat. We will reschedule for the heat period because the heat too. I'm not done preparing the slides. I just want to show you the slides I've prepared so far. Then I'll just end the class. Then use the 30 minutes left or 1 hour left to arrange the slides and send it to you right now.
Right now.
Then, yes, and within the week I will just do the heat. The only thing left now is the heat. Is that okay? Then
Yes, sir.
if we all agree to that, then I think I can just do that right now.
So we agree.
Okay. Okay, please, what about the scattering and the absorption? I don't know whether you didn't touch. You said you touch on it. You didn't touch on it.
Yeah, the scattering part. So hold on. I have some small parts in the scattering that you in the previous slide that I showed you. I think that is the only thing that I will touch on it. Hold on. So these are all the optics. I want to show you something under the scattering and the absorption. Okay. So let me just look at this part. You know, when light actually interacts with matter, as I explained earlier, it absorbs and it scatters some of them. The same way it reflects and refracts and interference happens and other things. Is that okay? One important thing that also happens, and it's very common, is the absorption and the scattering. The absorption happens to the extent that even if we wear black clothes, it's warm outside. like you feel really, really feel hot outside. It is because of this absorption. Is that okay? And even the scattering also helps because at the end of the day, if you wear a white dress, we get a lot of scattered light on the surface or reflected light, and at the end of the day, we get these kinds of temperature differences in the body. Is that okay? Now, in fact, let me show you something. These are some of the applications, but at the end of the day, what I want you to know is that anytime you are talking about transmission, it means the light that passes. This is a material, exactly our matter. Light that is entering is the same light that is going to exit. Like it's transmitting on it, it passes through. Absorption is when the light is incident on it, it absorbs it, it takes the light. It's like a foam. You pour water on the foam, it holds the water. Is that okay? Diffraction is when it encounter any aperture and reflection, it bounces on the surface. Refraction too, we've explained when there's a change in either the speed of the light entering or it bends away or bends closer to the normal. And scattering also behaves like this. And if it hits the surface, it just moves to any random position that it wants. The most important thing that I want you to know right now is the fact that we see red as red, we see green as green, and we see yellow as yellow. Exactly. If a plant is there, you see the leaf as green, quite green. Because at the end of the day, the light that is hitting the surface of this particular plant is not green light, it's a white light. It's okay. And now we know that white light comprises of a lot of colors in there. Is okay. So the thing that is going on is that we see it green because when the white light hits on the surface, the material absorb all the colors and reflect only the green light. And we will see only the green light. Is that okay? It is not our eyes or our mind perceiving the green light. It is what the leaf has reflected. Please, are we okay?
Yes, sir.
So you will see red, like the last one that I have here. We see red because the material is reflecting only what? Only red. All the white light hits the surface and it will absorb all the colors and allow only red to go out. And then you will see the red.
Sir, I have a question, please.
Hold on. So
Okay.
it means that if I have a black surface is not showing any color. Is that okay? It means it's absorbing all the white, all the colors that you are exposed to. The same way as white light. White material will not show you green or blue or anything. It means it's reflecting literally all the colors that is white. Is that okay? Yeah, Sir Francis, can I ask your question, please?
Okay, sir. Please, does it mean the leaf has a lot of colors and it is only the one it reflects, which is the green?
No. So the leaf itself has no color.
It means it has no color.
No. Sorry, let me not say it has no color. It has no pattern of, say, different colors in it.
Okay.
It is the material's nature to absorb some colors and allow some color to be reflected. Is that okay? So,
okay.
And I just want you to know that the material itself or the brain of the human is not perceiving any color. It is the material that is going to show us which is going to absorb and which one is going to reflect.
Okay.
Is that okay? So if we paint a wall and we paint it green, it means we know that the paint has a feature of absorbing all the colors and giving us only green.
Okay.
Is that okay? Because
Yes,
we know that this material, this is how it is. So why don't we paint it as brown? We know that this brown material we've created can absorb all colors and reflect only brown for us. Is that okay? So it's very important we understand this under absorption and scattering. There's another thing too I showed you before that I want to highlight on it. This thing. This is very important. When we take a black body like the sun is a very typical example of a hot black body, and it's coming to the earth. We have a lot of gases at the atmosphere. At the end of the day, it absorbs some and it scatters some. Is that okay? Supposing we don't have any gas and we have a prism here, you will see that it will disperse all the colors for us. Is that okay? All the colors very nicely. Then we get a very nice continuous spectrum. But if there's a gas there, it's going to absorb, depending on the gas there, it's going to absorb some particular colors there. Is that okay? Which is very important. Please hold on. Yeah. Please, are you understanding?
Yes, sir.
Yeah.
So if I have a lot of gases there, depending on the gas that I have there, it may absorb some of these colors. And at the end of the day, if I get a prism, then I disperse the colors. You see this black lines in between. You see, so each line represents a particular gas that absorbs the color that it wants. Is that okay? So it will hold some of them up there. And this is very important because it allows scientists to study the gases that we have at the atmosphere. And the gases that they are also abundant. Is that okay? So if you know this, that okay, we know that nitrogen or helium or any gas absorb around this particular wavelength band. Example, if it is exceeding, we can quantify it in concentration that, oh, we have a lot of this kind of gases, so it's not helping us or it's helping us. Is that okay? Which is very important. But there's another thing too. So you see, this is the same procedure of absorption, but in a different manner of what studies. The same procedure that these gases can hold up to these lights and later on re-emit them. Is that okay? It will absorb. And a time will come, it's not ready, they need to re-emit it. And if you remember re-emission, I spoke about it during the atomic physics part. Is that okay? So in giving out these lights, at the end of the day, the time that we don't need a black body and there's no black body here, like there's no sun, it will re-emit it. Then we get the colors that it actually absorbed later. Is that okay? So this ones, we call it emission line spectrum. Something like this, we call it absorption line spectrum. Something like this, we call it what? Continuous spectrum. Are we appreciating it a little? Hello, are you appreciating it a little?
Yes, sir. Yes, sir.
Yes, sir.
So, sir, for the C, you mean it is re-emit, the gases are re-emitting the one that they absorbed?
Absorb, that is all.
Okay.
So we gave it light, it absorbs some, we had the absorption light spectrum. Now there's no light or there's no sun. Then what it absorbed, it's re-emitted, then we get these ones. Is that okay? But there's no need for us to go further because there's another course that will allow us to go further, like very further in this. That is the physical optics. So this is what I want you to appreciate for now. Is that okay?
Okay, sir. Please, I have a question.
Please ask.
With the first one you explained, we know the colors of white light includes the 7 rainbow colors. So assuming I see a color which is not part of the 7 rainbow colors, does it mean that 2 or more of the rainbow colors have been reflected and the others have been absorbed? From what we know, some 2 primary colors may combine to form any other color. Is that what really happens?
Relatively, yes. So let me show you something here. The rainbow colors that we use as an example, if we come to the lab, it's not as rainbow colors as you see it. What I showed you in the prism, we have something called the district and we have something called the continuous. when it's district, you see that it gives you particular distinct colors. Is that okay? So that is about 7, right? Like distinct colors. But when we come to the lab and we put the prism there, it will give you a continuous light like this. And you see, this is not distinct, it's continuous. Like you see the continuous light of them. And it's ideally the same as what you mentioned, like blending 2 colors to form a different color. So, like we have a violet, it blends in with time, goes into blue, blends it with time, goes to green, blends it with time. You see, so here is the deep green, but going here is not really green. Then we go to the yellow, going down, go to the orange before we go to the red, you know. So it's ideally the same as what you are saying. But in teaching, we let the students know that it's distinct colors that we are talking about. But even in the lab, when we have a prism there and we disperse the light, you see the continuous light like this. Is that okay?
Okay, thank you.
You're welcome. Any questions so far?
So my question is not about this one, but it's about the practical. It's about the practical.
Okay, I'm listening.
The last time I said that some of us who are different center, for instance, I'm in Tamale Center. Some of the things we are disadvantaged. Some of this is, I'm not sure. The last time where the man was complaining that there are no material and those kind of things. So I don't know.
Okay, so maybe like you don't worry, go and experience what is there so far. Is that okay? If there's a need to do some online demonstration we can arrange and do that. Is that okay? But for now, we don't know what is available because I think code communicates to them, and if they are okay, they start. So I don't know how it's going to go this time around. Is that okay? So you just go and look at what is available and enjoy the ones that they are teaching you for now. If you come back and you think the ones that was taught wasn't enough, or maybe the equipment wasn't available to do it, I can literally also show a video or short videos of some of the things that you need to know. Is that okay?
Okay, sir. We appreciate that.
Okay. So
Please still
yes.
still on practical. And next week we those of us on the UCC Center. I hope are we coming on Saturday?
That one will be communicated to you whether you come on Saturday or Sunday because it's between chemistry and physics, I guess, right? So I think
There's no practical for chemistry.
Oh, okay.
This time around, there's no practical for chemistry, so
there will be a timetable. So I'm sure maybe I don't know. Let's wait till Wednesday. If we don't get a feedback, then we call code and ask them. They have to prepare the timetable and show it to us. Is that okay?
Oh, okay.
So let's stay put and wait. But personally, I will not be around the following weekend. But my senior colleague is also here, so he will help you. I've told him the things that you need to know, so he will help you go through. Is that okay?
All right.
Okay, so I'll see you. Okay, so thank you, everyone. So I still need 2 hours. Come again.
When are we scheduling the heat? When are we scheduling the class?
Yeah, we are waiting.
So there, I'll give you a time about it. Is that okay? When you give me time, I may disappoint you. So give me up to Tuesday, then I'll give you time. I'll suggest about some 2 days. If any of the day that is consistent with everyone, then we do it that way. Is that okay?
Okay.
So I think
Okay,
this
sir.
is what I've prepared so far, but I do want to add some feelings to it. Then that will be all. Is that okay? Okay. So have a nice day, everyone. I'll share the slides in
Yeah, we are waiting for it.
Yes, ma'am.
Okay.
I'll see you. Bye bye.
Thank you.
Okay. But yeah, man, join you.
those formulas. Yeah, I couldn't capture those formulas, so I'm finding difficult to work those questions.
Samuel, which formula are you talking about?
What do you call it? The first question that we solved, and then the second one. He
So
put
the
some
first,
formulas on the. I couldn't
yeah.
capture it.
Okay, all that they are saying about the slate is that when you are having the question about a slate or maybe a fringe, the fringe, you have to be able to identify the distance, that distance at the back where the diffraction occur is the y.
Okay.
Is the y. So you have to know that when you have the center line distance of fringe, that is the y that we have. So the moment you are using the y, we are saying that you have to get your lambda, y is equal to lambda L on D.
So y equals to lambda.
The lambda L on D. Now we know that lambda is the wavelength.
Okay.
That is what he has dropped on the. Lambda is the wavelength, and the length, the L is the length, which you see they have been giving you a length which is 0.003. Those kind of the length between the source and the slate. The length between the source and the slate, that is the L. And the distance, the D is the distance. The distance, the first one that we do say delta is equals to R minus 1, R2 minus R1. Then
Yeah,
the same
R2
R2,
minus
R1
R1.
is equals to D sine theta.
Yeah.
So that distance over there is always, which has been given to you as the D. So when you are able to know the y equals to the lambda L on D, the only thing that I have done, if it is bright, if the fringe is bright, you add m to it. The m, always the m will be given to you. That is the number order or the order number. So that it will be given to you. If the fringe is dark, then you have to add m plus
+1.
half.
Okay, plus half. Okay.
So that is the calculation that we did there. But for the change in y, you just replace, assuming you have adjacent fringe. The adjacent fringe is saying that whenever you are finding the adjacent fringe, you have to find what you call change in y.
Okay.
Is it? So when you are finding, you know that changing is like finding a slope. Change in m is m2 minus m1. Change in y is the same that y, but this time around, this one is not y1, a y2 minus y1. No. The moment you hear about changing y, it means the y will come with what? M plus 1.
Okay.
Which is the m plus 1 is the adjacent fringe. Minus ym. The m is the number order. That one it is called ym.
Please take that place for me again.
You are saying that the change in y is equal to is equal to ym plus 1. The m plus 1 is subscript.
Okay.
Y subscript of m plus 1 minus y subscript of m. Subscript of m. So when you're able to find that one, y subscript of m, you know that the m is the number order which has been given to you already. That one we have them. The same formula for y is what you put there in place of y, and you know the formula for the y is what?
Lambda L over D.
That's all. So you place the same formula there, then you'll be able to find your answer.
For okay.
Wherever you see Y, put lambda L on D over there. Wherever you see Y, lambda L on D.
Okay. Okay.
Uh-huh.
Okay. So I
Okay.
was
Don't go.
confused. The one that he worked, I realized that he placed some two. We made it Y2.
Y2.
Y2, and the two is the order of photo.
Yes, yes. That is the change in the Y.
Oh, okay.
And so that is it. But remember that you will not bring, when they say you should replace Y with the formula, you will not bring the M plus half and the M. This one is the adjacent range. So for the adjacent range, the Y change Y will come with M plus 1. That's all.
Okay.
So that is it. I think I'm good to
Yo,
leave the line. Okay.
thank you.
You're welcome.